our pneumatic product specialist.
All right, thank you very much, Sarah. Can you hear me all right?
Yes, I can.
Great, great. All right. Well, thank you guys all for joining us today. As Sarah mentioned, this is a Piab webinar focusing on centralized systems and decentralized systems. So I'm just going to walk you through kind of the basics of what that even means, decentralized and centralized, and to kind of walk through the differences between the two systems, common applications, quickly go through some of the products that relate to the two different types of systems, and some kind of tips or tricks to the trade of figuring out, okay, how's the easiest way to determine which system to use. So let's get started. Here we go. All right, so the centralized. So here, the gist of it is we got one pump for multiple cups. So obviously the centralized part of it is your one pump, and then you're branching off of that to your multiple cups. You can see in this first scenario, you're just going off and right in line. All the cups are coming in line, and we'll kind of touch on that a little bit later, but not the most efficient, as you can imagine, since there could be different vacuums, and of course if you've got blow off, then you're going to see different vacuum levels and blow off times. Then another layout, the more efficient layout for a centralized system is the second one, where you're going directly in a manifold, and then each of the cups is equally equidistant from the inlet of the vacuum. And so these are your two most common types of centralized systems. For Piab, you've got the compressed air driven pump, and then also out there on the market, you've got the mechanical vacuum pump. So these are like a rotary vane style pump. So these are the most common. Just to be clear, this is the type from Piab, and you'll notice later on we've got an application where we talk about how you can improve efficiency from these mechanical pumps by moving over to a compressed air style. And then the decentralized is where we've got one pump for each cup. So just a simple showing there, one pump each cup, and here you can see, as you can see, all the compressed air lines coming in, one compressed air line for each pump, and here you see the VGS series, and it goes that vacuum pump is acting directly on that cup. So instead of going through these airlines, all the vacuum getting drawn through all these airlines, it's getting drawn directly into that pump through that cup. And so this is a decentralized system. We do not have one pump that everything's running off of. Each cup has its own pump. So let's go through some benefits of a centralized system. Once again, just to point out, these are your two main types. So your compressed air driven style of pump and your mechanical vacuum style pump. So easy installation, fewer components. Okay, here, kind of makes sense right out of the bat, right? You've got one pump and then all your cups. So instead of having each individual cup with a pump, you just have one pump. So fewer components overall. No added weight to the end effector. This can be critical for a lot of applications where it's involving a robot, as you can imagine, where where milligrams, grams can count, and so they're trying to shave all the weight they can. So you just can't use a decentralized. You have to go with this, where your pump is off the robot or even on the side of the robot, and then you've got it feeding all of your cups. Vacuum filtration is a little easier, and primarily you've got larger lines, and since everything's kind of going back to one line, then it can be a little bit easier to introduce one filter instead of multiple filters, or so it is a little bit easier for vacuum filtration. And as you can imagine, the orifices inside these pumps are going to be larger than your decentralized units. Simplified vacuum sensing and blow-off controls. So, and that's really just, hey, I don't need any precise controls on each vacuum cup. We just want, hey, I just want pretty easy. I either have vacuum in my system or I don't, and I just want to give it one command and have one blow-off. No extra thrills, nothing. So, just very basic, simple system. And so along with all of that, the fewer components, simple sensing controls, blow-off controls, you're of course going to have lower initial cost. So now some drawbacks to the centralized vacuum system. Reduced product handling safety. So as you can imagine, if you're handling let's just call it a big pane of glass, right? If you're using this type of system to handle a pane of glass, and all of a sudden you've got a leak in any one of these cups or anywhere in this vacuum line, then that's going to affect the whole entire system. And so that of course affects your safety and your ability to maintain handling of that product. Vacuum flow restrictions, that kind of along the same lines, we've got all this tubing, the multiple cups all affecting each other. But since we've got these extra elbows and all the plumbing between the pump and the cup, then of course all of those are adding restrictions to the vacuum flow. Difficult to zone. Zoning is, if you just think of zoning as control. So to be able to have control over whether it's just one cup or control over, a couple cups together. But a lot of times, or not a lot of times, but many times, you want to have separate zones. So maybe you're trying to pick up 4 different parts, and you want to be able to control each individual part. You can't do that very easily with a centralized system, since they're all working together. Reduced response time. So if you just think about how in this case with the compressed air driven, you still have the time of reaction from wherever this pump is located to pull a vacuum through all of these cups in order to evacuate all of this volume before you're getting to that peak vacuum. And especially with the blower pumps, since these usually have to be running all the time in order to be able to react quick enough in the process, and still you still have to evacuate all this line to be able to pull your peak vacuum on your system. And even also with blow off, right? Because with blow off, you're going in reverse, then you've still got to fill all those lines before you get that that true blow off experience. And increased energy costs. So all of this adds up to that. So any leaks in this system, you're going to be, going through energy there, losing compressed air costs, and a lot of times these are oversized. Both of these systems are to basically make up for any leaks in the system, or just all of this volume that is needed to be evacuated. There's kind of a necessity to oversize it, and so that all adds to energy costs. Difficult to troubleshoot. So as you can imagine, if one of these is not working and it affects all 4 of them, then it becomes a little bit trickier to pinpoint exactly where you're having the problem. And so and that's the case for both of these style systems. Possible false gauge readings and signals. So, depending on where the gauge is in this system, if you have the gauge on the cups or at the pump, because they're all drawing from that same volume, from the same plumbing, then you're going to have different levels of vacuum depending on how quick the process is. That vacuum difference is going to be seen across those cups all the way back to the pump. And so there's that chance of having faulty gauge readings or false signals on achieving the appropriate vacuum. Uneven vacuum and blow off. So as I mentioned, you know, in that first instance back on the first screen where the cups were in line, or even in this instance where they're coming in and, you know, they first go to these two cups, well, chances are those two cups are going to be, you're going to start pulling a higher vacuum across the first ones, you know, and they're going to see the blow off first as well. So just having that inconsistency with where you're going to see your vacuum and your blow off coming from can cause problems. And I mentioned this before, more difficult to size correctly. So once again, what I mentioned before, whether it's, you know, taking into consideration leaks or, you know, evacuating all this volume, the tendency is to make sure that you oversize the system so that you aren't running at, you know, at your maximum capacity all the time. So here's just a breakdown of kind of 3 different design layouts for a centralized system. So here you see it's more kind of just in line in a way where, you know, you're going to a manifold and then you're going from cup to cup. And then this is the least efficient and probably going to give you the most problems because you're not getting that the equal reaction of the vacuum and the blow off. And then in the middle, slightly better, but still, as you can imagine, these are still closer to that vacuum source than these cups out here. And so this is just a 4 cup, but if you can imagine, you know, 12, 16 cups in a scenario like this, you can have a very big difference between the first cups in the system and the cups at the very end. And then the best case scenario for a centralized system is where you've got your vacuum coming into one source, and then from there, it is the same distance to every cup in that system. But also you can imagine this this becomes almost impossible when you've got lots of different cups just because of how they're laid out in the array. So here's an energy case study. So here's a case erector, and this is kind of just pinpointing the biggest energy savings between a typical rotary vane mechanical pump, or some people call them blowers, but mechanical pump, which is seen up here. And then down here, we've got the Pi Classic from Piab, so a compressed air-driven pump. And so the biggest benefit we have here is with the compressed air style, we're able to, since you're getting that reaction as soon as you apply that compressed air, we actually have the ability to shut off that vacuum when you don't need it. So while the mechanical pumps, typically you've got to be running them during the whole process to be able to react quick enough, you can turn these compressed air driven pumps off when you don't need it. And so that's what you're seeing during this chart. And so you can see where the red line is your mechanical pump, where you aren't able to turn it off. And so it's just running the whole time, and this line is just basically showing you your energy consumption, as you can see here, over time. And then this green line is showing you how, all right, I need the vacuum on, all right, now I can shut it off. Okay, now I'm back on, off, back on, off. And so over time, you can see that there's a potential for large savings. In this case study, it was about a 40% energy savings. So just one little example of how even within centralized systems, there's ways to gain efficiencies by updating or upgrading your vacuum pump source. So here are some typical applications. In the packaging world, pulling blanks, carton and case erecting, case packing, palletizing. So if you think about this, you've got lots of cups that are usually acting on one fairly light part. Safety isn't usually a big concern here because you know, you typically don't have an operator getting in the way of this. Excuse me. So there's not a big need for any type of part present or sensing or feedback. It's just, hey, we need to just keep this rolling and have lots of cups acting at the same time. And so that's where this centralized system, there's not a need for that extra degree of control and safety. And then on robotics, as I mentioned in the beginning, this can be as simple as, hey, we just don't have the weight. We have to shave everything off, and so that's where a centralized system can be used on robots more, or seen more. And then you know, it talks about tool changers. So as you can imagine, if you only have to worry about the cups for each set of tooling, then it becomes a lot more cost effective if you've got a large number of tools that you're changing out. Plastics, mold removal tools, kind of the same concept up here. Not a need for multiple zones. You just have lots of cups acting on one part. Sheet metal handling and glass handling. Sometimes, although you'll realize in a little bit later for the decentralized, you get a lot more safety and control when you're handling these with decentralized systems. So this just, I'm not going to get into the weeds of these products, but I just wanted to give you a little snapshot of all the product offerings, or most of them, that Piab offers. So just a large variety of sizes, you know, all the way up to you know, the MLL, which is, you know, 540 SCFM, and here's the one high compact that you're more likely to see for robot, for end of arm tooling. So just wanted to give you that, and also to give you kind of an understanding that it's not just so easy to be like, okay, I want a vacuum pump, just give me one. You know, they do, in order to get the most efficient one, we do want to make sure that we're sizing it correctly for the right the flow and the depth of vacuum that is needed for the system. So on to the decentralized. Sarah, are there any questions so far for centralized?
No, I don't see any questions so far.
All right, good deal. So now on to decentralized. So once again, this is where we're talking about one pump for each cup. And this is just a quick snapshot of, hey, this is what you'll see a lot of these out in line. And then this is what you're seeing even more of, are the VGS style. Here we go. So some going through some benefits. Instant vacuum and release. So as before in the centralized, where we had to go through the plumbing, here the vacuum pump is directly on that cup, or even for these inlines, they're usually very close in proximity to the cup. So you just get much faster vacuum evacuation and the release. Smaller plumbing lines. So if you think about the centralized, we had to have plumbing to be able to pull the vacuum through all of that plumbing back to the pump. Where in this case, we're just supplying compressed air to that pump. So no longer do we need the larger size of plumbing here. So even that can actually help save some on plumbing costs, but then also just weight and just the hassle of it. Easy troubleshooting. So before, where you have a problem with a cup and it affects all the other cups in the whole system, here, if you have a problem with this cup, all three of these are still reacting to their full capacity. They've got their own supply source, but more importantly, from that vacuum source, you know, there's nothing interfering between all these cups. So it's much easier to pinpoint where that problem cup is. Flexibility. So this has to do with that easy troubleshooting, kind of, since you have control over each cup, and it becomes much more flexible in the control you have, the options you have per cup. So whether you want to add the part sensing to that cup, getting some feedback here. And so, anyway, so just having that extra control over each cup allows you just an endless amount of flexibility, and whether it's, you know, filtration or part sensing or blow off, much more flexible. Increased safety. So back to that windshield example or any sheet of glass. Once again, as you can imagine, you lose one of these cups or two of these cups, you still have full capacity from those other cups that are still holding on to that window. And so many times the systems are designed so that you can have you know, one or two cups or whatever they decide that can go out, and you still have enough force holding that windshield in place. And most energy efficient. So going back to the centralized, where you had to deal with all the plumbing and accounting for any of that vacuum, any of that pressure drop through all that plumbing and any fittings leading out to the cups. Here, because you're pulling that vacuum directly on that cup, or in the inline case, very close to the cup, you're getting maximum efficiency for that component setup. So some drawbacks to the decentralized. One, of course, is your high initial cost, right? We've got one pump per cup, so of course your price is going to go up a little. More sensitive to dirt. Same reason why the centralized was good, because it had the larger lines, and you know, usually you just had one source of you know, one line to kind of protect. Then if here, of course, you've got multiple pumps to protect, and the orifices are going to be smaller. Having said that, there's a lot of cups come with screens and filters, and there's also other options for, you know, for filters between the pumps and the cup. So it's not, you know, that you're completely out of it if you do have some contamination in your system, but it is certainly more sensitive. More vacuum switches are needed. So of course, if you've got more pumps and you want to make sure that you're switching, you know, for each cup, then of course you're going to need those additional switches. And of course the added weight to your end of arm tooling. So vacuum problems. Hey, parts aren't getting held on. I just need a bigger pump, right? So this is a case to where this customer, plastic bag handling, and so they had a Pi Classic, and they had a single cartridge system, and so they weren't getting the consistent picks. They wanted to be getting around 50 picks a minute, and they weren't getting there. And so and then in addition to that, they were having some problems maintaining the part. So they thought, well, we'll just, you know, throw another cartridge in there, get twice the flow, and that should be good. We should be able to take care of it. Well, they didn't see that much improvement. So they reevaluated. As you can see, a little bit larger tubing than we'll see in the next screen, and they decided, hey, let's try going for a decentralized system. And so they switched out the single pump and went to individual pumps for each cup. Here you see a VGS SX12, and so this is just a plastic bodied VGS, and so to decrease that additional weight that they were concerned about. But here you'll see air usage went down, and because we're getting a much more efficient system, the vacuum flow went up substantially. And so that efficiency in the system, whether it was just needing that extra vacuum flow, but in a more efficient system, not having to worry about any leaks or pressure drops in the centralized system, they were able to fix their problem and to gain more control of their application and their picks. And as you can see, yeah, the decentralized system, you know, it costs a little bit more, but let's face it, for $116, that's usually a drop in the bucket for when it comes to production increase. And when you can go from 40 parts a minute to 50 parts a minute, then you're doing all right. And that's what this is showing right here. So typical applications for decentralized. So some of the same that we saw in the centralized, but here once again it's more about control, speed, and safety. So when you need to have faster pick times, faster blow off times, you need more control with your with multiple parts or part sensing. That's when you want to go to the decentralized system. And you see it right here with the robotics. When you've got high-speed pick and place systems, you're going to be going towards a decentralized system. Same thing with these plastics. And then down here you'll see the sheet and glass. You know, we talked about with the centralized systems, but here, when it's important to have that extra level of safety and energy savings, and that simplified troubleshooting, then it's a very easy decision to go with a decentralized system. So now I'm just going to take you through some of the product offering from Piab for decentralized systems. So to start off with, this just the kind of the lowest end, the value line, just to replace some of the competition. Very inexpensive, easy, lightweight, and the Pi-in line. So these are in the same family there, just very easy to implement, inexpensive. And then basically the bigger brother to these inline. So these are still your inline style. And as you can see, you've got them here on the end of tooling. And this is a great way to bridge that gap when you need to save a lot on weight, right? Because these aren't going to be nearly as heavy as the VGS series, but it's going to give you faster reaction times, and that's why you see these in stamping facilities and in automotive applications. And here's the vacuum gripper solutions, the VGS that I keep mentioning. And so there's just a big family of VGS products and offerings here. And ultimately, as you can see, this is where you can mount the cup directly to the VGS itself. And you know, there are times where you can't use that the cup directly to it, and so there are people that actually, you know, they still have a line going out to that cup. They just want the functionality of the VGS because as you'll see through these slides, there's so many variations and so many options, whether it's blow off or different levels of energy savings. Lots of very flexible solution here with the VGS series. These chip pumps, the Pi chip, and you'll see this the P3010, and you can see actually here these are some of the series that can actually be used for both, just depending on, hey, do I put, if I've got a much larger cup, for instance in this application you got a much larger cup, so that is a decentralized setup, but you need a larger pump for that. And so so these pumps can be used in both types of setups, just depending on how much flow and vacuum you need to achieve. And of course over here, you see their series for attaching to collaborative robots with the foam. And then here is just to give you a little snapshot of the of all the options that Piab has come up with to focus on the safety and energy saving aspect of vacuum systems. So as those become critical factors for plants, then we're traditionally, you put a mechanical pump on there, just slap some whatever pumps we need, and let's just get it going. Now there's a little bit more accountability in the design and considerations for these vacuum systems. And so Piab has just put together a whole plethora of solutions to to figure out whatever degree of safety and energy savings you need. They've got something for you. And so to break it down, how do you choose centralized or decentralized? So hopefully you have an idea by now. But centralized, to break it down again, we're looking at weight is critical, right? There's really no options for putting anything on there. We've got to get it really slimmed down. That could be a case for centralized. Higher tolerance for dirt and debris, no zoning required. Just one part, no need for multiple parts, anything like that. Individual cup zone sensing is not required. Falls in line with this. Very basic one-off system, no bells and whistles. Little safety concerns. Going back to the case packing and moving cardboards and case erectors, all of those. Typically you don't have an operator right there standing there, so safety is not a real concern for them, or dropping cardboard is not a concern. And then of course the simple controls are desired. So for a decentralized, you're looking at applications that I've got multiple parts, or I want the highest level of control I can. I want to be able to have max speed, robot picking places, whatever it is. Energy efficiency is important. Lower total cost of ownership. So as you can imagine, if we're getting a much more energy efficient system from the decentralized, then our total cost of ownership is going to be drastically lower. And that's one thing to really point out to the customer, because usually it can be a little bit of a sticker shock when anyone is used to, hey, I've got this centralized system and I want to improve it a little bit. It can be a little bit of a sticker shock going up to having an individual pump per cup. But when you think about, oh, it's maybe $100 or $200 extra, whatever that might be per cup, that's a one-off expense where you're going to be reaping the benefits of the energy efficiency and the productivity of that machine from having that control. And along with that, your safety is a high priority. Part sensing is required. Downtime is critical, and easy troubleshooting. So as you can imagine, when you factor in these types of criteria, safety, downtime, and easy troubleshooting, the added cost, the added initial cost of doing a decentralized can easily be accounted for when moving to one pump per cup. So what's my preferred choice is the decentralized. Now, of course, I don't always get the choice, and like you saw in some of those cases, you don't have the option. You have to go with a centralized, because whether it's weight or you just don't need all the bells and whistles. But for the most part, when customers are when anyone is trying to look for a solution where they want more control, more efficiency, less downtime, and saves money over the total cost of ownership, then generally speaking, your decentralized system is the way to go. So with that, that wraps it up. Hopefully, wasn't too brutal for everyone. And if there are any questions, doesn't look like there are any questions, so I must have answered all of them for you guys. And so with that, thank you all for joining, and look forward to having you guys again.
Thank you, Doug. I appreciate that. It was a great presentation. And if anyone has any questions, feel free to put them in the chat, or I'll email out Doug's contact information as well. And do know that we have future webinars coming up next Tuesday and Thursday of this month, and so check out the list if you're interested. And thank you again for coming.